So this tutorial, I just want to go over rate law determination again, but taking it in a different way, where before we were dealing with experimental values that we figured out, and calculated and everything else. This case, though, we want to base it more on observation and what you might see in the lab. So again, we previously determined rate law using experimental data and the values that you might measure. But there are also ways of being able to figure out observations, and from those observations being able to figure out your elementary reactions. And once you have those elementary reactions, then you can go and figure out the rate law from that. So within these next couple of tutorials, I'm going to go over something called the initial step of a reaction mechanism. Now, the initial step of a mechanism will go and dictate how that mechanism is going to react and operate. So it is very essential to know, what type of step you have. And what we want to deal with in this tutorial is just, what happens if you have an initial slow step. Now, if you have an initial slow step, basically that's where your reaction mechanism is going to stay for most of the overall reaction, and then once that reaction is done, then it'll go and finish everything off. But because of that, that's where your rate law can actually be determined. So let's go through and try to figure out an example like this, where you have a reaction mechanism. In this mechanism, you have two different steps. Those steps aren't occurring at the same rate. The first step will be slow, the next step will be fast, and so in this case, you need to figure out what your reaction law is actually going to be, or kind of predict what it's going to be. And you can do that by looking at, again, the slow step, because of the fact that you're going to stay in the slow step for the duration of the time. And, now to do out the rate law, you do it just like you usually would, where it's just basically rate equals K, and then take your reactants, which for the slow step it's O3 and it's NO2. And that would be your rate law for this particular reaction, again, because of the fact that you're staying in the slow step for so long. So let's try another type of example. I guess in this case, again, you're looking for the rate law. You have a mechanism. Your mechanism has steps that aren't occurring at the same rate. One's fast and one's slow. You need to figure out what the rate law is going to be because of that. So look to see what your slow step is. In this case, the very first step happens to be the slow step, and so you can go and actually determine your rate law from that. So rate equals K times the concentration H2O2 and I negative.